And we'll go ahead and call the meeting to order. Mr. Coley, could you note that all the commissioners are here?
So noted.
Commissioners, as you know and recall, in the past years, we have had members of our leadership development program in attendance to observe the board meeting. Over the next 5 months, we will have the participants from this year's class in attendance. I would like to welcome this year's participants. We're happy to have you, and I want you guys to stand up and introduce yourself and tell us where you work.
Good afternoon. I'm Bill Wolfenbarger. I've been at KUB going on 29 years now, and I'm a supervisor in our underground construction division.
And he's working a water break, isn't he?
Afraid to say so.
Hello, I'm Kevin Roberts. I've been at KUB about 25 years, and I work in the station management service, the wires department. So glad to be here.
Hi, I'm Audra Richards. I work in the accounting department, and I've been at KUB for about 10 years now.
Hi, I'm Lori Hartzog. I work in electrical engineering, and I've been here about 6 years.
Good afternoon. I am Trina Gallman, and I work in the communications department. I've been here about 7 years.
Hello, I'm Wayne Britnall. I work in the rates department just downstairs. I've been here for almost 11 years and primarily work on purchasing natural gas.
Welcome, and I promise you this is probably not going to be the most interesting thing that you have done in your class. But we're glad that you decided to come and be a part. All the commissioners should have got a copy of the minutes. If everything is okay with the minutes, could I have approval?
So moved.
Second.
All in favor?
Aye.
Any opposed? Well, we're going to go right into our official actions. Commissioners, the mayor has appointed and the city council has confirmed the appointment of Jerry Askew for a 7-year term as a KUB commissioner. I know I speak for all of us when I say how pleased we are to have Jerry join us on the board. I would like to recognize Bill Coley to administer the oath of office. And this is the fun part.
See you at
Yeah.
Make sure we're at the right place. Is this okay?
You're good.
All right. If you will, please repeat after me. I do solemnly swear
I do solemnly swear
that I possess the qualifications required by law
that I possess the qualifications required by law
for the office of KUB Commissioner,
for the office of KUB Commissioner,
that I will support the Constitution of the United States,
that I will support the Constitution of the United States,
the Constitution of the State of Tennessee,
the Constitution of the State of Tennessee,
the Charter of the City of Knoxville,
the Charter of the City of Knoxville,
and the bylaws of KUB,
and the bylaws of KUB,
that I do not have any contracts or business interest with KUB
that I do not have any contracts or business interests with KUB
that constitute a conflict of interest,
that constitute a conflict of interest,
and that I will faithfully discharge
and that I will faithfully discharge
and perform with fidelity
and perform with fidelity
the duties of Commissioner
the duties of Commissioner
without fear or favor,
without fear or favor,
to the extent of my skill and ability.
to the extent of my skill and ability.
So help me God.
So help me God.
Congratulations.
Thank you.
Welcome.
Thank you.
We're going to next have the election of the 2016 officers. The charter requires that the board to elect officers each year following the new commissioner election. I want to recognize Bill Coley to conduct the election.
Commissioners, last month, the nominating committee nominated a slate of officers for your consideration. You will recall that the slate of officers is as follows: Nikisha Thompson, Chair; Sarah Pinnell, Vice Chair; and Mark Walker, Secretary. Are there any other nominations? Hearing none, is there a motion and second to elect the slate by the nominating committee?
I move that we select the slate.
Second.
All right. The motion has been seconded. All in favor, please say aye.
Aye.
Are there any opposed? Then the motion carries and these officers are elected, and congratulations.
Thank you. We're going to move on to Resolution 1339, authorizing participation in the TVA startup and testing program, amending the existing rate schedule of the electric division to provide for the STP rate schedule. Samantha.
Commissioners, this is a new pricing option that we want to make available to our customers. We think it will support the economic development mission of KUB, and I recognize John Williams to provide you the details of this rate.
Thank you, Ms. Roach. Good afternoon, Commissioners. As you know, over the years, we have presented various TVA pricing programs and requested participation in those programs when we feel there's a benefit to our customers. Resolution 1339 authorizes KUB to participate in an optional TVA pricing program that's designed for some of our larger industrial and commercial customers. It is called Startup and Testing Power, STP. This program is designed for our larger industrial and commercial customers, and with that program, it provides an optional pricing mechanism or optional flexibility that provides a discount when power use for customers during a startup of an existing operation, testing equipment for an expansion, or restarting an existing facility that has been shut down for a period of a year. Large commercial or industrial customers with over 1 megawatt of monthly power requirements could be eligible for this program. And with this program, it is subject to interruption with an initial term also to those customers of up to 6 months, 12 months for commercial customers, and up to 24 months for industrial customers. With this program, I think a picture is worth 1,000 words. And as you look at this example chart here, we have hourly power consumption for this customer and hourly intervals over a 30-day billing cycle. And what you'll see is this customer as an example of one who has existing base load who will be testing equipment for an expansion. Their average or their contractual demand base load is under 100 kilowatt hours for each of those hourly intervals. And as they're testing that equipment, that jumps up to between 350 to 750 kilowatt hours during those hourly intervals. While each customer's power usage and their base needs and their testing needs will certainly differ, what is the same is that each time the customer, KUB, and TVA will work together to determine what that base load power requirement is. And then once that's determined, usage above that is subject to that STP rate as set by TVA. We translate this customer example over into a customer bill. In that same example, a customer would save $3,800 on their monthly electric power bill if they are eligible, and that equates to 32%. From a KUB perspective, KUB continues to recover its costs as it would normally. That discounted portion is in the TVA part of the monthly electric power bill. Certainly, as those customer profiles differ, their electric use, their testing needs, the savings would also certainly vary from customer to customer. So this resolution, 1339, if approved by the board, would authorize KUB's participation in TVA's startup and testing program, power program, or STP. It would also change the existing electric rate schedule to add STP. Because this is a change to the electric rate schedule, it does require 2 readings. The second reading will be presented for the board's consideration in February. With that, I'll be glad to answer any questions you may have.
Anyone have anything? I request a motion and a second for Resolution 1339 on first reading.
Move its approval.
Second.
Is there anyone here from the public that want to speak on this? If not, Mr. Coley, could you please call roll?
Yes. Commissioner Hamilton?
Aye.
Commissioner Herbert?
Aye.
Commissioner Pinnell?
Aye.
Commissioner Thompson?
Aye.
Commissioner Williams?
Aye.
Commissioner Worden?
Aye.
Commissioner Askew?
Aye.
Resolution 1339 is passed on first reading.
We'll go into the president's report.
Commissioners, I'll remind you that several years ago you passed an ethics policy that applies to the board as well as all employees. That process includes an annual disclosure, and Elva Marshall will be recognized to explain the details to you and to submit to you your annual disclosure form.
Thank you, Ms. Roach.
Commissioners, as you know, your job requires for you to meet regulations and laws related to ethics. And these all date back to the city charter, Resolution 1, which was the first resolution adopted by this board, and the present day, when in 2000, as Ms. Roach mentioned, this board adopted the conflict of interest and added it to the bylaws. In 2005, we added a employee conflict of interest policy. That also included a disclosure. I'm happy to report that all of our employees have completed that disclosure for 2015. In 2006, the state took a much more interest in the process and established an ethics commission. The ethics commission is required that all municipalities across the state adopt an ethics policy, which this board did in 2007. In 2012, when we updated the bylaws, we updated the ethics section as well. And then in 2013, this board elected to also add a disclosure component. The disclosure component is seeking to align with any governing statutes, laws, and guidelines, as well as to certify compliance. And you're certifying that you understand the requirements related to political activity, that you do not accept gift or gratuities, that if there is any personal or financial interest in voting and non-voting matters, that those are disclosed, and that you do not have any improper use of your position, authority, KUB facilities, or property. This disclosure is included in your packet today. We just ask that you complete it and submit it by the end of January. And any questions? All right, thank you.
Thank you, Ella.
Again, we'll remind you that we have monthly reports on each of our systems. Today is the report on the electric system, and I will preempt Paul Randolph's report by saying we only have one person with a power outage at this moment. So hopefully the system is strong and performing well. I recognize Paul Randolph.
Thank you very much. That's a nice introduction. I appreciate that, Ms. Roach. It is my pleasure to be here today to talk about the electric system, and was just back up the last day or so. I looked at the report that came out this morning, and over the last 24 hours, I think we had 10 events on our electric system. So that is what we would say would be like a normal, what we call blue sky day. So nothing adverse to the electric system the last day and a half due to the winter weather we've experienced. And that does speak to the strength of our system. I think that's where I hope this presentation takes us to at the end. You'll recognize the electric system is a strong system. We've done well with our Century 2 effort programs, and I'll highlight a few of those for you today as well. So let's just start off with a overview, if you will, of the system itself. And the electric system is the largest of our 4 utility systems. So I wanted to point that out. It also was very complex. I've had the fortune to have worked with all 4 of our divisions in the gas, water, wastewater, and the electric. And I will tell you from my perspective, and I think from most people's perspective, the electric system, there's more components, it's a complex system, but KUB has done a great job with it, and it performs quite well. We do have, if you'll note here, we do have the in-feed substations. Those are the points at which we receive our power from the national electric grid through TVA, and that's metered and delivered to us. And then we send that around our system in these black dots representing 63 substations, where we take that power and we send it down to the next level and then further distribute that to ultimately to the customer. 7 counties, 5,300 miles of wire out there on the system. You'll hear me talk about overhead wire and underground wire here in a minute. It's noteworthy that about 5,000 miles of that is overhead, and 200 plus near 300 is underground. So we have programs related to those. Like I said, 4 major components of our Century 2 program that I wanted to highlight today for you in this overview: substations, overhead facilities. We talk about poles and the associated facilities with that, the wires, etc., underground cable, And then kind of a somewhat unique animal is the downtown network. You've heard us talk about the network itself and the differences that system has over our others. Looking back to last year, I wanted to remind everyone of the recently completed Cherokee Trail substation completed in March. It serves the UT Hospital and Cherokee Farm areas, but it does much more than that for us. It improves our reliability in general for the system. I'll show you a map here in the future of how we're all interconnected, and it allows Century 2 programs at other substations to take place, because you have to take a substation out of service in order to upgrade it, and in order to do that, you've got to have redundancy and reliability and other components of the system to make that happen. So this kind of blends into this year's program, although this March of 15, that was last fiscal year, but it does play into where we are working today on the system. You heard again last fall about our recently completed East Knox in-feed substation. That was the 9th in-feed in our system, and it's taken us 10 years from the concept of that substation and the need being realized in our engineering group that we need to bolster our supply on the east end of our system. So we've worked for many, many years to bring that program about. We share this site with TVA, and if you step back in this photo here, you say, man, that's a large piece of property. And it is. Here, right about this area right here is where the property to the north or to the upper right, that's the KUB facilities, and this larger section to the lower, that's TVA. So a large facility, we don't occupy all of that. We do receive about 330 megawatts of power. I think if you go back to the original, I think our total system is about 3,000. So about a third, about a tenth of our system, as you would expect, power from TVA will come through this station. And again, this brings up the support in the east and the south part of our system, and that's where we really benefit in the operational flexibility. As I mentioned earlier, the work we completed at Cherokee Trail helped us to start the University Hospital upgrades there. So because of the work we've done before, we are now able to move in this year and upgrade the University Hospital substation, and we're adding capacity there. You'll see a new transformer being delivered. Matter of fact, it was just delivered the 14th, I think, of this month. So it's just rolling on site in that photo, and we are increasing the capacity of that station from, I think it was 36 or so, and now we've upped that to 50 some odd megawatts in that area. So increased capacity. Now, as a part of Century 2, there's many other things that are going on. Not all of our Century 2 work includes increasing capacity of the station, but it does include refurbishing all the components. You can see here in the Arlington substation, these insulators, so all of the insulators, and there could be 150, I think, or some odd number like that in this Arlington substation itself. All of those are being replaced with new insulators, new breakers, new equipment. So when we leave any Century 2 substation work, we're in essence leaving the station refurbished like new. So brings it all up to today's standards. You don't see on here the third station, that's Island Home. We have another station that's scheduled to be worked later this spring, that'll be Island Home. It does not have any transformer additions to be made there, but again, it will be refurbished and brought to like new standards. Typically under Century 2, we have 3 to 4 substations per year in our programs going forward, and we're on pace to maintain that work. Moving over to the overhead facilities, like I mentioned earlier, we have transmission overhead and distribution overhead. Most of our poles in our system put in the 60s and the 70s. Distribution poles, typically a 50-year lifespan. The bread and butter of our system on distribution poles are wooden, the standard height being 45 feet. We use wood poles for the most part there because they're readily accessible. accessible from the roadway, and being at 45 feet in length, they're easy to move around the system and install, and they are inexpensive at about $250 a pole. That's not a lot of expense. We do use other products like ductile iron. In many cases when we have the need to have a lot of equipment on the pole, for example, you've seen us bring wire down the side, we're going from overhead to underground, and we have other attachments on the poles. We need greater strength, then we'll install ductile iron. Now, a ductile iron pole will cost you about $1,250 instead of $250. So quite an increase, but again, we want those poles to stay there a long time. They're not susceptible to rotting or decay, those kind of things that you can see in wood. There are cases where we install now concrete poles, typically when there's moisture in the ground, where things will be wet, and we're concerned about the ill effects that might have on metallic or wooden products. So we do install them, but they're quite heavy, and the crews really don't like to take those out there and manhandle those around the job site too often. On the transmission side, now that's a different animal because most of that work is off the roadway. So we have to haul those materials back on the private easement routes a lot of times. And the pole of choice there you see at the bottom is steel poles. Steel poles, the typical steel pole there is about an 80, 85 foot pole. The steel poles might be $6,000 a piece, and the wooden pole of like size would be about $2,000. So that's $4,000, and that seems like a lot of money, but in the bigger picture of what it takes to install a pole and to move a pole around the system, there's distinct advantages from not having to pull a one-piece 85-foot long wooden pole versus a steel pole which comes in sections. So we can haul out these sections. They're easier, they're lighter weight. You can pull them back across country with lighter equipment. You don't have to bring a large crane in. There's all kinds of operational and construction advantages in using the steel poles. We've got some engineering folks here, and they'll tell you, well, on the transmission poles too, these things in steel, they're designed specifically for that location. So when we know what the wire size is, we will design the pole for that one application. It's designed to have the right tolerances for the load it's carrying, so strength is considered, the angle at which we might need to put additional supports in there, such. So they're kind of one-off designs. Now, when we talk about poles, we got to understand we're going to go out there and do pole work. We're also going to be looking at what other features are out there attached to it, mostly the wires. Many times we will upgrade the wires on the system, transformers, etc. So we generally talk about overhead facilities and pole replacement, but when we do that, keep in mind there's a lot of other equipment out there attached to the pole that gets renewed as well. The pole replacement program in our Century 2 was about 2,600 poles a year, 26,000 over a 10-year period. You'll note here in this year, we actually reduced that target to 2,000 poles, and you would say, well, why would we do that? Well, I'll show you on the next slide, we're a little bit ahead of the program. We had some good success over the past years. In the first 5 years of our program, we've been able to achieve our targets within our budget and actually get some additional poles in there. So what we focused on this year was increasing the transmission poles. They're much more costly. You can do fewer of them for the same amount of dollars. So we turned the program to focus more. So we've got more than we actually have achieved 200 poles so far in the first 6 months. So we're going to get ahead of the program on our transmissions. So that's the focus right now. The green line is interesting. We changed this. It's not a linear installation. If you think about it, construction doesn't work quite that way. So we've recognized that usually in the winter months we don't get as much work done. But if you'll think back about November time frame, it was nice and warm outside, we kept working. So we're ahead of the game now, but certainly we are going to taper our installations to meet our targets by the end of this fiscal year. So again, over the 5-year program, we're on target. We're going to be right at the number come July 1 of this year. And looking forward to the continuation of this program to accomplish our 10-year plan. Told you I had another little map back here. I wanted to kind of point out a few things about how we work on substations and then how that affects how we move power about the system. Now, the lines here are multicolored, but these conductors are the 69 kV system that interconnects the substation. So we have a loop system. If you'll remember, a couple of months ago, we talked about the gas system and the advantages that we had with the new loop pipe system there by the South Loop addition. We have that same feature in the electric side where we have the ability to move power in different directions around these loops. So you'll see that, I can point a few of them out here. I wish the text was clear enough for us to read. It's not even clear enough for me to read. I'm this much closer than you are. But right here is the East Knox in-feed substation. So we just completed that. Right here is University Hospital. We have Arlington right there, the lighter green. So we're working on those areas right now. You'll see some conductors that we're working on. Specifically, I wanted to point out this one right here. This is Chapman Highway. So if you're going up down Chapman Highway, you see a lot of crew activity, a lot of activity there. So where are we heading next year? Again, taking a quick look right here on this. This is Shook's Gap, this orange dot. Well, we're holding off on that because when we work on Shook's Gap next year, we need to make sure Chapman Highway is done. Because when Chapman Highway is complete, we can feed from this direction, and we'll feed from this direction, and we have the break in the system right there at Shook's Gap. So we're timing these projects, and our engineering folks do a great job working in coordination with our operations and our construction folks to have an understanding about how the system is going to be performing, where we can make these breaks and schedule this work out. And we've got to schedule this out in an additional 10 years about how to continue this program. Underground distribution cable, our focus has been on direct burial cable, and it's been on that program since Century 2 began. The life expectancy of direct burial cable is less than it is if it's in conduit. You would say, well, that makes a little bit of sense because it's out of the environment. It gives a little bit of space around there to help the cooling effect of the cable, because anybody knows that electrical components heat up, and heat is the enemy of any electric component. We've got 58 miles left in the system, and we're on target to complete by 2020. If you go back to 2008, we had about 140 miles of cable in the system then that was direct burial, and we were having failure rates of 1 per mile per year. That was unacceptable. Century 2 kicks in. Work on program right now that the failure rate last year was 3, so that's about 1 for every 20 miles. Our goal continues to be 0, but just before the failure, we want to be scheduled. We want that scheduled replacement to take place. So we're balancing that program. It's been very effective again to reduce any outages, and everybody knows a customer that has a planned outage is a lot happier than a customer without a planned outage. So we're trying to avoid those and doing a good job. Moving into the last of the 4 areas I want to talk about is our downtown network improvements. And just as a reminder, in March of 14, we completed an 8-year program where we went in and refurbished all the vaults. So when we say the vaults, if you go outside the middle of the building, you step on a gradient out there, if you were to go into that hole, that's one of the vaults. There's a lot of electrical equipment in there. We went in and refurbished all of that equipment. We went in there and cleaned the vaults out and resealed the walls of the vaults. All of that stuff has taken place. 97 of those, all of our vaults downtown have been refurbished. So that takes us into the next phase of the program. Let me point out here if I can, wish this was just a little bit brighter, but the green area is identifying the network limit. So inside of that is where we have our network. It's fed by 2 substations, the network substation and the Center City substation. So that's feeding into the area. So as we move into the phase 2 of the program, we're going to start working on the components that are between those vaults. what's the vault feeding, whether it's a primary line, a secondary line, et cetera. And I think there's 5 different components of our program going forward. I'm going to quickly go through those in this process. First thing is primary cable. We expect to do about 10 blocks, about 400 feet per block, so about 4,000 feet a year. The first one of the first ones here is the network cable that you'll see identified here. There's also a piece of cable here and here, but this network cable right here, the largest section, is we call network 32, and you would say, well, gosh, it's awful close to the center city substation. Why is it called network? The network's so far away, but if you'll remember, the network substation is now sitting there on Henley Street. It used to be sitting right where the Knoxville Convention Center is, so it was the original downtown network beat. So that's the original paper and lead cable primary line that serves all the way from over the network on the west side of our system to the east side of our system. After we do the 4,000 feet, or in conjunction with that, we have other projects underway, and we have some secondary cable. Secondary cable is the cable between the transformer and the street over to the customer, or street lights, so a little smaller diameter, service wire. We've got several blocks of that, about 1,600 feet of that, and you'll note we're coordinating that with the city streetscape projects, excuse me. So, you know, we're conscious of what's going on in the community as well, so we're working with the city. You've heard in the recent past about some other work downtown with our other utilities and the water, wastewater, electric, and some gas, and we're coordinating that effort as well. So if the streets are torn up and we can take advantage of that from an electric perspective on our upgrades, we're coordinating that effort as well. In addition to that, we have a switchgear replacement program. We've identified 4 areas this year to focus on. The L&M STEM Academy, Crown Plaza, Digital Crossing, and Center Square. You'll note that those are also connected to some of the primary cable work we're doing, so we're using that to prioritize some of the work. A switchgear, and there's a picture of one down here, but in essence what that does, it allows 2 primary sources of power to come into this piece of equipment, and one of those services would be the primary, the other is secondary. On this gear right here, the top of the gear is the outlet to the customer, and if it senses that one feed, the primary, is down, it automatically switches over to the second. So there's no interruption or momentary interruption at the most the customer would see as that switches power. And this is one of the features of being on the network, is that the switch gears there are available, and we have multiple feeds, and they're looped together in the downtown area, improving reliability. The next pop-up here is about some vault grading. Like I said, when you step out of the millers, you see the metal grading there. Well, over time, those become dislodged, or they need to be refurbished. So we have actually like a 25-year program to go out and reset those gradings, work with the city on some sidewalk repairs, and get all that stuff back in the top shape. Manholes, about 12 per year, so you can see a lot of these are associated with other projects. So when we're replacing cable, we're also going to go back down in the manhole and look for improvements to the physical manhole itself, but also some of the equipment and some of the racks that are in there to help hold the cable up for our service work. So, again, part of the whole network improvement program. Bottom line, the results, what we're looking for is reliability. I think as much as anything, our society expects to turn the switch or turn the computer on and get the power right up. So that's certainly our goal, and we have a metric, a corporate metric, which you're very much aware of. This year is 2.0 hours of interruption per customer or less. Again, we kind of use this, instead of straight line representation of the gold. We kind of looked over the history and said it really kind of looks more seasonal. So that's what that represents. The blue line is where we are right now. And a few anecdotal comments. You may have remembered this one as well from one of our 25-year veteran in our overhead construction group. Anecdotally, our folks will tell you when they go out on the system and work storms like yesterday, or they're on the system looking to replace 69 pole lines work, they're very pleased with the condition of our system, and it improves safety and work conditions for them, and they see it as being a more reliable, robust system. Again, a strong system. So where do we want to be after 10 years of Century 2, and that's around 2020, 2021 timeframe. We do expect to have 26,000 poles complete, about 20% of the system. All that direct buried cable is going to be gone. 90% of our substation will all be modernized. And as a part of that, our communication network, where we talk to our system, our substations, will be replacing some of our older copper systems with new fiber systems, and that work is being done in conjunction with the 69 line replacement work. In summary, I think we are a strong system. We continue to be driven by our Century 2 programs. We do measure the effectiveness of those programs, and as we said with our pole replacement, we make minor modifications where we can to best benefit the programs that our customers service. I think that's about it. Is there any questions or such?
Yes. How many entities do we, that service our pole, that we have using the poles that we use? I know you have Comcast and folks like that.
How many attachments?
Yes.
Well,
maybe a question for another day.
Well, that's probably something I can get back with you with, but I think that we have, while we have paper ventures, there's probably 3 or 4 or 5 different ones. Of course, they're not necessarily all on the same pole. They have service territories somewhat. I would speak to my own neighborhood. I think that if somebody else has got a foothold in there, that doesn't mean it's attractive for somebody else to come in there. So there are many persons attached and companies attached, but I don't know the number. I can get back to you.
Do we charge them a fee to attach to our poles?
There actually are pole attachment fees, and that's something that's kind of live in the news right now about how they should be calculated. So there's ongoing discussions as we speak on those.
There are state involvements and TVA involvements with all the distributors right now in what the pricing for those attachments should be. It's important for everyone to be fair with the commercial side of business and not to discriminate. And of course we don't, but it is a good source of revenue for KUB.
Proving myself to be a rookie, tell me the difference between the transmission pole and the distribution pole.
I apologize. The transmission system for us is our higher capacity, where we buy power, we send it across a 69 kV system, 69,000 volt system. We call that our transmission or sub-transmission lines. Those feed the substations. The substations take the 69 power and reduce it to 13 kV. And that's what you'll find in your neighborhood or down some of the main thoroughfares even. And that is then delivered to the house, and usually your system there will take it, reduce it to 240, 120 volt, I don't know what you got, or your business maybe 480 volt or something like that. So it's, if you go down, I'm trying to think of someplace close by, you might see, if you go down Nayland Drive, you see some very large tall poles. You look up those are the 69, that's the transmission poles for us. Yes.
I have a compliment and a question. The compliment is that I was talking to a client recently in Sequoia Hills who, the question was, are you going to get a generator for another property? And he said, in the last 10 years, we've had barely any outages, where it used to be kind of common. And he does not know it's on this board, as far as I know, and on the tree trim policy, I did say, well, it's probably because they're trimming trees. And he said, yeah, they know how to do it. Well, I wanted to pass that along because I think it's a testament to your good work. My question has to do with saying kind of similar thing about my work, is that in the last 6 months or so, I've recommended to 3 clients to bury lines in front of their house. 2 are KUB customers, the third is a LCUB customer. And the reason to bury are mostly for aesthetics. And secondary reason would be, in these 2 particular properties, we would like to grow trees along the road that would grow to a height that we wouldn't be able to with the lines. And I guess my question is, from your perspective regarding maintenance, does that add more to your work, having those lines underground? Because I'll probably continue to recommend that in situations where it's to the client's benefit, but I've never asked the question to you, and I see 25-year lifespan for underground. That seems a very, very poor life expectancy. So can you talk about that a little bit about the,
I would say that the 25-year expectancy is really related to the direct burial cable. We're getting better performance out of cable and conduit. Cable and conduit is easier to maintain, but if you think about it, trying to identify where your problem is, if we have a storm event this weekend and we have outages, our guys are going to go out at night in their vehicles and they're going to drive down the road with spotlights looking up, and they can see a cable break or they can see a fault on the line. You can't necessarily, you can't see that underground. Now, you can identify it's between 2 sections of the buried cable, but you don't know exactly in that cable run where the fault is. So the solution many times is you pull the whole section of cable out and slide it to an end. So identifying where the problem is takes a little bit longer. The repairs most likely take a little bit longer. So there are some expenses associated with having an underground system that you wouldn't necessarily use great for the overhead. But there's benefits for being underground, as you mentioned, and they're valid. And what we see now in our system is most of our residential development for many, many years has been underground. They want to go underground. It's attractive. We enjoy having it on our system. Right now, I think, as I mentioned, already about 5,000 miles of our system is overhead, and only 250 or something odd is underground. So.
Thank you. I do actually have one last question. It was about the vaults.
Yes.
Where you're refurbishing. I was kind of a curiosity question. Did you find anything surprising in certain areas of the city where the water table is different, or the fill material around it's different? Do they all need to be upgraded consistently? And if not, did you change the life expectancy as a result of this work? I'm just curious about what you learned.
That whole 8-year program on the vaults included encapsulation and cleaning of the complete vault. We went in and cleaned all the concrete. We moved all the equipment out of the way so we could seal it completely. So it is in essence, a watertight vessel now. So if there is any kind of work done in there, if someone wants to have an oil spill in there, for example, we can clean that right up. We don't have any problem with that at all. So they are new, in essence.
So
watertight. So water table
you might have
around
to
this.
do that for a long, long time.
Not my life.
Yeah.
Yeah. It was a very, very good program.
Any more questions? All right, thank you, Paul.
I would like to just add one comment to Paul's presentation. This is another example of one of the things I think that KUB does well, and that is stewardship. All that you heard about Century 2, the hard work of our engineers and operations and construction is really about preventing problems for our employees, and that is something that they deserve a great deal of credit for. But we couldn't do it without the funding that this board gives through the Century 2 program. So never think that we take for granted the hard decisions you have to make to fund those programs. All of this work you're seeing is because of the funding plans that we have that you have approved, and you will see again this April in our half-day meeting. So we thank you for that. Speaking too about stewardship, Because we run our water system, we pay a lot of attention to what happens throughout the rest of the nation. I know, like us, you all have been quite concerned about the failures at Flint, Michigan and their water system. So I've asked Erwin Haygood to update you today on how that could not happen. And you've heard I said, could not happen.
You are correct, that's right. If you turn the TV on, it doesn't matter if it's the news or not, you're going to get some report about Flint, Michigan. They truly are in a crisis situation. It's a situation that I could not ever foresee being here. To let you know that they've been in a crisis situation for nearly 2 years, and it just seems unacceptable for that to be the case. What's happened is about 2 years ago, they changed water source. And by changing the water source, there probably wasn't enough planning, thinking, acting in order to do the right thing. As a result, there's lead in the water. They're having to pull water. They can't drink the water. So what I want to do today is let you know a little about Flint, a little about what happened, why it happened, and why it will not happen here. And that's Flint. It's a city department, and quite honestly, they had some financial situations that occurred to them back in 2011 where the state took over financial responsibility of how they spend the money. If you look at here, there was a plant built in 1952 in Flint. Well, about 50 years ago, they decided to quit using that plant. They started buying water from the city of Detroit. And so they're buying treated water, and all they're doing is sending it out into the system. It's already pre-treated. They don't have to use any treatment process to go into Flint, Michigan. Well, with the budgetary control in 2011, there was also basically an emergency kind of manager that was put into place to kind of take care and oversee some of the activities. And they were trying to reduce some costs. And so one of the things they did was they kind of decided, wait, we can, that mothballed plant that we built in 1952, how about let's build that back up. Let's get it back up to speed, quit buying water from Detroit. The deal is that in Detroit, they were getting water from Lake Huron, a good quality water source. And Flint's water treatment plant was going to get the water from the Flint River. It wasn't quite as good a water quality source. In fact, I read a little bit about it, that just the raw water itself, pre-treated, the corrosive elements within the water in Flint River was 19% greater than the corrosivity of the water in the Huron. Now, keep in mind, Detroit was even removing all any corrosive activity because they treated and they put corrosion inhibitors, et cetera, and so that, it was exponentially worse than what it was before. So anyways, let's go a little bit of the timeline, kind of what happened. In April 2013, that's when they decided to save some money. And what surprises me, and within a year they turned the switch and they went to the new water source. First of all, I don't know how you can possibly do that in a year. They had to upgrade the plant, they had to do planning, they had to test, put in some new components. You would assume. We don't know all the details there. But somehow within a year, they had the water going from the Flint River. Immediately, they started getting water quality issues. It was color, taste, and smell. It was almost immediately. And so the entire city of town of Flint was getting bombarded with all kinds of calls about the water quality. And then shortly thereafter, just months, you started getting boil water orders because they had bacterial issues and notices within the system. And they had some other violations. In fact, 6 months in, General Motors, who had an engine manufacturing plant there, realized that their engines were rusting. The parts of their engine were rusting with that water. So they were fortunate they had another water source, so they quit using the Flint River water. And so they just disconnected that and got to another source so they can continue to make engine parts. So all this was continuing to happen. Then notifications that there was lead in the water. And when we say lead, it's elevated levels of lead in the water. Then it started finding out that the children were having lead in their bloodstream. Indicators, pretty significant indicators that something was wrong. EPA also, I'll note, on April of 2015, recognized, for some reason that they just then recognized, that there was no corrosion control. corrosion control is a significant element of a water treatment system to make sure your system is in good quality and in good shape, that the water is of good quality. You put a corrosion control, basically a chemical that you add to your water, like you do chlorine, you put fluoride, and you put a corrosion inhibitor into your water. What that does is keeps your pipes from scaling or taking off elements of the pipe and causing it to go into what you drink. So in essence, a corrosion inhibitor kind of puts a little bit of a coating on the piping, and it also prolongs the life of your pipe. Well, without a corrosion inhibitor, you can see what happens. Anyways, ultimately, October of 2015, a long time since they started having all those issues, they finally decided to go back to the original Detroit water system, okay? But that doesn't mean it's over. The pipe had lost all its corrosion inhibiting surfacing, so the pipe had corroded more, so you're still leaching the pipe into the water system. So that's where they are today. And obviously you can see the federal government got involved, and that's where we are today. And I'm going to put together here just a few items what I would perceive to be some of the contributing elements. First of all, they wanted to cut costs. That seemed to be a very, very, very high priority to them. Second, I think they wanted a deadline within 1 year. To me, that just doesn't seem realistic, but they had 1 year to achieve that result. I don't think they did enough planning. They didn't do possibly jar tests and pilot testing on the water and the chemistry of the water and how the chemistry and the chemicals they could add to the water would modify the characteristics of the water. In essence, there was inadequate regulatory oversight. I can't imagine how, if we were involved, that our regulators would not have guided us in a different direction, quite honestly, and had more oversight. And I've said already about the quality of the water source. They did not have a corrosion control program. They had inadequate monitoring in the system, obviously, because if it took that long to react or to find out you've got problems, in my opinion, I think you don't have enough monitoring in your system. And then when they did find out, I think they had slow response